Now all this is the cube root of 1005, which is approximately f of x, which is the cube root of 1000, plus f prime of 1000, 1 over 3, 1000 to negative 2/3, and times dx, which is 5. You had no idea that you could approximate, not exact, right? Approximate the cube root of 1005 so easy. And you can say, I don't see this. In a moment, you will. The cube root of 1000 is 10. The cube root of 1000 is 10, but it's squared, so it's 100, plus 1 over 300, because it's power negative, it goes 1 over, and 5 at the top. I will simplify. So I have 10 plus 1 over 60, 601. You had no idea that calculus will teach you to approximate the cube root of 1005 with such a simple number. You can say, now show me. Okay, I'll show you. And I'll show you here with 1005 to power 1/3. No, I didn't mean that. I meant this. 1/3. And then 601 divided by 60. You had no idea how powerful calculus is. Good. Do we need to illustrate with another?
A question.
Yes.
So let's say instead of 1005, it was 1015. The problem.
Still 15. Still 15 is a tiny error by comparison to 1000.
So then dx would be 50.
Yes, but we are really interested in something closer to that. But yes, in that case it will be. What if I have, for example, the cube root of 998? The function is still the cube root. What will be x and what will be dx in this situation?
Good question.
So remember, dx could be positive or negative. It doesn't always have to be positive, because you could be on one side or the other. Anyone?
Dx would be 2.
But negative, right?
Negative 2.
So I cannot choose dx before I choose x.
X 1000.
Yes. So first I have to choose x, and then I realize that the dx is positive or negative. Same thing, because that's the closest to taking the cube root of 1000. Can we move on to a word problem, or we want to illustrate with another example?
Can we do another example?
Yes.
I have a question as well.
Please.
So basically, do we have to find the d of x like first? Because
no, you have to find x first.
Okay, and we're just like guessing?
No, we look at the cube root.
What if it was like 1000 and the next highest cube root, and it was like right in between those? How would we know which one to choose?
Well, you have to choose the closest to what you can take the cube root from, because it's an approximation. So your question is very good. So for example, I'm here. So this is my x. I cannot approximate using the differential here. So because this is such a huge distance. So I can approximate what's happening here with the tangent line at this point. But if it's too far out, then the error will be too large. I can still approximate, but so all this idea is with something close. So if I have this as 1,000 and I have here as 2,000, I cannot approximate. I'm not happy. The error is too big. So I can approximate what happens near 1,000 if I'm looking at 1,005, at 998, even 996. But if I want to be at 2,000, it's a different story. I can't. So for 2,000, I have to use something else that is close to 2,000. Does that answer your question?
I don't really know. Like, what if we have this exact same function, like the cube root, and then we have like cube root of a number that is directly in between like 8 and 27, because those are both perfect cubes.
Okay,
Which one did we go to?
So it depends. So if it's 26, you'll use this. If it's 9, you'll use this.
So you don't think we'll ever have a question where it is in between?
No.
Or just theoretically?
Yeah, but let's take a look. Okay, so the square root of 26. Obviously, it's 5 and 1. The square root of 8, obviously, is 9 and 1 with negative. A square root of 102, obviously, it's 102. 103, 103. The cube root of 28 is 27 and 1. So by definition, dx is tiny. If dx will be, 20 or whatever, much more, then there's no, that's not called an approximation anymore. So we can approximate if we're close. If we're not close, we can't approximate. It's a very good question. Does that answer your question now?
Kind of. But we can move on.
Okay. So do we need to do, I think F said, okay, so can you choose another? Can we choose another problem from here, or you can make one up?
Maybe one with like a different function or something like that. Like not a cube root, maybe like exponential or something.
Okay, so what about if we want to approximate e to 0.2? So this is approximately f of x plus f prime of x dx. So we have to identify the function. We have to find f prime. We have to find x and dx. Good. We just made one up. Which function are we talking about here?
E to the power of x.
Excellent. Which derivative are we talking about here?
E to the power of 0.2 times,
So if this is f of x, this is f prime.
Oh, okay.
Right? Perfect. Now let's identify x and then identify dx. So now we are looking at this. Which is the closest number to 0.2 that you can think of?
Whole number?
Yes, of course.
Well, 1.
So,
Unless you mean 0.
0. Very good. Can anyone give us dx?
Zero dx.
No. We're talking about
Point
0.2.
two?
Yes, exactly. 0.2.
Oh,
We answered the problem. We have this, we have x, we have f prime, we have dx. Done. So I'm going to continue here. So x is 0. How much is f of x?
E of x.
How much is f of x? So we plug in 0 in e to the 0. How much is e to 0?
0.
No. Any
One.
number raised to 0 is 1,
One.
except 0. So this is 1 plus f prime of 0.
Zero.
No,
No?
it's the same, right? It's the same function. F of x and f prime of x are the same functions, and I plug in 0. This cannot be 1 and this can be 0, right? So 0 here gives me 1, 0 here gives me 1, right?
Oh, yeah.
Good. Times
I was
dx.
confused.
So 1 plus 0.2 is 1.02. You had no idea that you are capable of approximating e to 0.2 with a simple calculation. Well, calculus allowed us to do that. You can say, show me, okay, and I'll show you. It's a very good approximation because the number is very close. I mean, the error is very small. So e to power 0.2 is 1.22. Okay, and we got 1.02. The exponential function, the thing is, with the exponential function, as you know, we've been dealing with this since 2020. A person gets sick here, 2 days later, 50,000 are sick, and then 2 days later, 100,000 are sick. So this is has the fastest growth. So you can approximate. So that's exactly what it says, approximate. Good. Can we look at a word problem now with this concept?
I have
Yes.
a quick question.
Yes.
So what exactly is like 1.02 equal to? Like what's the symbol that it is equal to?
This is this is approximately this, but this is exact equals this. So this is approximately this. So e to 0.2 is approximately 1.02. This is all we are saying. So here we are saying that the cube root of 1005 is approximately 601 over 60. Here we're saying that e to 0.02 is approximately 1.02. Here's the approximate symbol, but from here on, these are equal. So there is no problem here. But now when I draw the conclusion, this is approximately this. Is that better?
Yeah.
Perfect. So now I want to refresh you before we choose a problem. I want to refresh your memory on marginal or marginals. We talked about this. So C prime of x, it's called the marginal cost. P prime of x, marginal profit. R prime of x, marginal revenue. Lazy people do this when they don't want to rewrite the same word that is above. So C prime marginal cost, P prime marginal profit, R prime marginal revenue. So we want to use the concept that we just looked at to approximate cost, revenue, whatever. Okay, let's take a look. I just want to choose a marginal profit, cost. Okay, marginal cost. Let's take a look. Marginal profit, marginal revenue. Let's look at marginal revenue, 31. And you see how we apply what we just looked at. Solano Carriers finds that its weekly revenue in dollars, R of X, I'm copying it, 0.007x cubed minus 0.5x squared plus 150x. I copied it. So this is in dollars, and x is units. Units, number of units, whatever suitcases, it's not important. So they are currently selling 26. So that's my x, 26 units. Fine. What is the current weekly revenue? So that's part A. Any suggestions on how to determine that? We are manufacturing 26. We're assuming we're selling them. So what is the what is the current weekly revenue? How do I determine that?
You just plug it in.
Of course. So I'm going to put the function in. So in y equals, I have 0.07x cubed, and then I have a minus 0.5x squared, and then plus 150x. Okay, so I plug in 26. Perfect. And I get 3685.032. Awesome. Back to part B. How much would revenue increase if sales increased from 26 to 28? So part B, from 26 to 28. Okay, let me refresh your memory. What is delta X?
Two.
Excellent. So what will be the exact error? Exact. How much? How do I determine it? Can anyone tell us how to write it?